Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to AP Chemistry course. Today we will start on chapter 1, Atomic Structure and Properties. Moles and molar mass. The mole is the counting unit used by chemists to indicate the number of atoms, ions, molecules, or formula units present in a particular chemical structure. The mole is similar to other counting unit that you have used before. Bear means 2, dozen means 12, gross means 144. What about mole? 1 mole means 6.022 times 10 to the power 23 of molecules for molecular compounds, or formula units for ionic compounds. The molar mass of a compound tells you the mass of 1 mole of the substance. In other words, it tells you the number of grams per mole, of a compound. The units for molar mass are therefore grams per mole. Well, there is a quantitative connections between mass of substance and number of particles that the substance contains. N number of moles equal mass of compound divided by molar mass of compound. So if we divide mass of compounds over the molar mass of the compounds, we get number of moles. See, here we have mass unit grams. Unit for molar mass grams per mole. So grams will go with grams, and the unit, of course, will be moles. Now, if we multiply number of moles times molar mass, that will give us the mass of the sample. Moles will go with moles, and the unit of the mass will be grams. To find the molar mass of a compound, what we have to do, use the chemical formula to determine the number of each type of atoms present in the compound. Multiply the atomic weight from the periodic table of each element by the number of atoms that element present in the compound. Add it all together and put the units grams per mole. Grams per mole after the number. You have to. As an example, find the molar mass of sodium carbonate. Here is a formula. Na2CO3. How many sodium? We have 2 sodium atoms. So atomic weight 23 will be 46. How many carbon? Only 1 carbon. From the periodic table, atomic mass 12. So that's 12. We have oxygen 3. So oxygen, we have 3 oxygen. Okay, times 16, that's 46. Add them together, that will be 106 grams per mole. What is the molar mass of calcium carbonate? We have only 1 calcium times 40. 1 times 40.1. How many nitrogen? See, we have NO3 to the 2 here. So we have 2 nitrogens. We have 2 nitrogens. So 2 nitrogen times 14, that will be 28. How many oxygen do we have? We have 3 times 2, that makes 6 oxygen. So oxygen, 6 times 16, that's 96. We add them together, that will be 164.1 grams per mole. Grams per mole. Calculate the molar mass for lead dichromate. Well, we have only one lead, 207. How many Cr we have? Chromium. We have 2 times 4, so that's 4. And how many oxygen? We have 14. So we have 4 chrome, that's times 52, makes 208. Oxygen, 14 oxygen times 16, that makes 224. Add them together, that's 639.2 grams per mole. Remember, all the units given here are grams per mole. We are talking about molar mass, which may be abbreviated as G per mole, grams per mole, G mole minus 1 to the power minus 1. Remember that if you don't use a unit in your answer, the answer is wrong. Okay? Practice problem. For 35.00 gram of ethylene glycol, which is used in ink for ballpoint pens, calculate the number of, first calculate the number of moles, then calculate the number of molecules. Given the atomic weight of carbon is 12.011 atomic mass unit per atom, hydrogen 1.0079 atomic mass unit per atom, oxygen 15.9994 atomic mass per unit. Well, in this formula, ethylene glycol, we have 2 carbons, we have 6 hydrogens, 1 in here and 2 in here, 3, 5, and 6. So we have 6 hydrogens, and we have 2 oxygen, 2 oxygens. So what we have to do is multiply 2 by 12.011, 24.022. Hydrogen will be 6.0474. Oxygen will be 31.994, 31.9988. Well, we add them together, we get the number. Now, after the decimal, we have here 3 digits. We have, after the decimal, we have 4 digits, and we have here again 4 digits. In addition and subtraction, we get the least number of digits after the decimal. So, for addition and subtraction, use the following rules for significant figures. Okay? Count the number of significant figures in the decimal portion only of each number in the problem. Add or subtract in normal fashion. Your final answer may have no more significant figures to the right of the decimal than the least number of significant figures in any number of the problem. So we have again here 3, we have here 4, and we have here 4. The least will be 3, so we have here only 3. And the molar mass will be grams per mole. The first request is to calculate the number of moles. The number of moles will be the mass divided by molar mass. Number of moles will be 35.00 gram divided by 62.068 gram per mole. To determine the number of significant figures, we use the following 3 rules. Number 1, non-zero digits are always significant. Any zeros between significant digits are significant. Final zeros or trailing zeros In the decimal portion, only are significant. For example, 0.500, these zeros are significant. 0.632000, these zeros are significant. However, 0.006, 0.00968, the zeros are not significant. So let's go to our calculation. 35.0, so these zeros are significant. We have four significant figures. Here we have 1, 2, 3, 4, 5. This zero will be counted, so this is 5 significant figures. The least is 4 significant figures, so we'll stick with 4 significant figures. In the product will be 0.5639 mole of ethylene glycol. The second request is to calculate the number of molecules. The number of molecules will equal number of moles times Avogadro's number, which is 6.00 10 to the power 23 molecules per mole. Right? So mole will go with mole, and the unit will be number of molecules. Again, we have here 4 significant figures. We have here 4 significant figures. So that will be 3.396, 4 significant figures, 10 to the power 23 molecules. See you next session.